On December 24, NASA officially adjusted the status of 3I Atlas, classifying the object as dynamically evolving and subject to structural stress, a move indicating that observation systems have recorded a transition into a phase of serious instability. New data show that the self-rotation rate of 3I Atlas is rapidly accelerating. The core nucleus is exhibiting clear tensile deformation, while non-gravitational thrust from jetting gas streams continues to maintain strong intensity rather than diminishing. This chain of phenomena suggests that heat from the Sun has penetrated deep into the interior of 3I Atlas, triggering the sublimation of ancient ice pockets that had long been isolated, thereby generating extreme internal pressure capable of weakening and breaking physical bonds that were already fragile. In this context, the orbital deviations associated with 3I Atlas colliding with an invisible barrier surrounding the solar system can no longer be regarded as random disturbances, but have instead formed repeating data structures implying the existence of a physical influence not yet fully explained, or a fundamental change in the nature of the object's motion. The core of the issue therefore lies not only in the phenomenon itself, but also in the interpretive gap, and the lack of transparency from scientific institutions in the face of signs that are becoming increasingly difficult to ignore. Next, we will examine how 3I Atlas has changed following NASA's latest announcement. The story of 3I Atlas quietly changed when scientific language shifted because classifications rarely evolve unless observation forces them to. For months, 3I Atlas occupied a familiar category, one that allowed astronomers to describe motion as stable, interpretable, and ultimately predictable. This stability mattered because when a body like Atlas fits inside an established label, its behaviour can be smoothed into expectation without resistance. That expectation began to fracture when updated internal summaries redefined 3I Atlas as a dynamically evolving and structurally stressed object. Such language is deliberately restrained, yet within scientific culture, it signals that previous assumptions about Atlas no longer hold. When 3I Atlas received this revised designation, the change did not announce danger, but it quietly acknowledged transformation underway. The dynamical state of 3I Atlas now implies motion that cannot be fully described by gravity alone, even when known corrections are applied carefully. Non-gravitational forces had always been present in Atlas, yet earlier models treated them as diminishing echoes rather than persistent drivers. What distinguishes the current state of 3I Atlas is not the magnitude of deviation, but its coherence across independent measurements. Classification systems in astronomy exist to compress complexity, and when Atlas no longer fits, the system must stretch or fail. By revising the status of 3, Atlas researchers effectively admitted that the object had crossed a conceptual boundary. That boundary does not separate natural from artificial, but separates passive evolution from active dynamical change. The updated language surrounding 3I Atlas reflects motion that responds to internal processes as much as external heating. Atlas is no longer treated as a body merely cooling as it recedes, but as a system still reorganizing itself in response to earlier stress. This reorganization suggests that 3I Atlas carries delayed consequences from its encounter with the inner solar environment. Dynamical evolution implies time dependence, and for 3I Atlas, that dependence is now measurable over remarkably short intervals. Such sensitivity unsettles long-term modelling, because Atlas cannot be assumed to relax smoothly into inactivity. Instead, 3I Atlas behaves like a system negotiating balance rather than settling into it. Within this shift lies a subtle emotional tension, because classification changes are not just technical adjustments, but admissions of uncertainty. 3. Atlas becomes a reminder that scientific categories are provisional agreements with reality, not permanent truths. As the dynamical label changes, Atlas invites a slower gaze, one that watches process instead of outcome. This moment does not declare what 3I Atlas will become, yet it marks the instant when prediction gives way to observation. From here forward, Atlas must be followed rather than assumed because its motion has begun to write its own terms. The first indication that 3I Atlas was no longer behaving quietly emerged not through imagery but through rhythm, because rotation leaves signatures that light cannot hide. Astronomers tracking Atlas noticed repeating patterns in brightness patterns that rise and fall as surfaces rotate into view, and for a time those patterns aligned with reassuring precision. This initial regularity allowed 3I Atlas to be treated as a rotating body with a stable internal balance, a familiar assumption grounded in decades of cometary observation. As monitoring continued, the data describing Atlas began to shift not abruptly, but persistently, and persistence is where significance often hides. Light curves derived from 3I Atlas no longer stacked cleanly when extended across multiple nights, even when accounting for instrumental uncertainty. Each recalculation suggested that Atlas was rotating slightly faster than before, a change small enough to overlook yet consistent enough to resist dismissal. Rotation acceleration in an object the size of 3 Atlas carries meaning because angular momentum does not alter itself without cause. In conventional models, jets of gas escaping unevenly from a surface can apply torque, slowly adjusting spin rates as material leaves the nucleus. For Atlas, however, the observed acceleration exceeded the gentle drift expected from fading outgassing alone. What deepened concern was not merely that 3I Atlas was spinning faster, but that the rate of change itself was increasing over time. Measurements taken 24 hours apart showed detectable differences, implying that Atlas was experiencing ongoing torque rather than a single impulsive event. Such behavior suggests that 3 Atlas remains dynamically active even as distance from the Sun grows. When torque persists, structure must respond because rotation translates internal stress outward. For 3I, Atlas increasing spin implies rising centrifugal forces, especially along regions extending farthest from the rotational axis. If Atlas were uniform and solid, such forces might distribute evenly, yet observations already hinted that internal cohesion was far from uniform. Here the anomaly sharpens because known physical drivers struggle to sustain this pattern without modification. Outgassing jets can spin 3I Atlas, but jet activity usually weakens as volatile reservoirs deplete, leading to deceleration rather than acceleration. The continued spin-up of Atlas implies either that volatile sources remain abundant at depth, or that internal pathways are opening rather than closing. This interpretation bridges rotational data with thermal evolution, because heat does not halt at the surface. Energy absorbed during perihelion continues to migrate inward, within 3I Atlas activating volatile pockets, delayed by insulation and depth. Each new release from Atlas contributes additional torque reinforcing rotation, rather than allowing stabilization. Emotion enters quietly here, not as alarm but as unease, because accelerating rotation transforms 3 Atlas from a passive traveller into an active system. Atlas begins to resemble a body negotiating competing forces, one pushing outward through spin and another holding inward through fragile cohesion. This tension carries narrative weight because acceleration implies direction rather than drift. The story of 3 Atlas at this stage is not about imminent failure, but about imbalance accumulating without resolution. Every incremental increase in rotation nudges at last closer to thresholds where material strength matters more than orbital geometry. The dynamical state of 3 Atlas now feels transitional, suspended between endurance and transformation. This section leads naturally forward because rotation does not exist in isolation. The accelerating spin of Atlas prepares the ground for deeper structural consequences that begin to appear when shape itself starts to respond. As rotation accelerated, the physical response of 3I Atlas began to reveal itself, not through equations alone, but through geometry. High-resolution imaging of Atlas no longer showed a comfortably rounded inner region, the shape long associated with a single cohesive nucleus. Instead, 3 Atlas displayed a stretched inner structure, one that appeared elongated and uneven, as though opposing forces were pulling the core in different directions. This deformation matters because shape is a record of stress, and 3 Atlas was beginning to record more stress than balance. In a rotating body, centrifugal force grows with distance from the rotational axis, amplifying strain in protruding regions. For Atlas, this meant that irregularities within the core were no longer cosmetic features but focal points of mechanical tension. Images of 3I Atlas suggested a structure approaching a bilobed configuration, with 2 concentrations of brightness connected by a thinner bridge of material. Such a configuration does not confirm fragmentation, yet it indicates that the internal cohesion of Atlas is being challenged unevenly. In systems like 3 Atlas, uneven stress distribution often precedes structural reorganization or failure. Centrifugal forces act continuously, not episodically, and as spin increases they exert a steady outward pull. For 3 Atlas, that pull acts against material held together by weak gravitational binding and ancient brittle cohesion. Unlike solid rock, the interior of Atlas is likely a composite of ice dust voids and fractures, each responding differently to stress. This is where the concept of a pre-disruption state becomes relevant. A pre-disruption state does not imply imminent breakup, but it describes a condition in which internal forces exceed previous margins of safety. 3 Atlas appears to be entering such a condition where deformation accumulates faster than the structure can redistribute stress. The visible stretching within 3I Atlas suggests that rotation is no longer being absorbed elastically. Instead of flexing and returning to equilibrium, Atlas seems to be reshaping itself in response to sustained torque. This reshaping reflects a system adapting under pressure rather than resisting it. Material waves observed in the surrounding coma add another layer to this interpretation. These arcs indicate episodic releases of material from 3 Atlas bursts that coincide with moments of internal adjustment. Each release reduces local pressure while transferring stress to adjacent regions within Atlas. Emotionally, this stage of the story introduces quiet vulnerability rather than spectacle. 3 Atlas is not exploding, not shattering, and not announcing catastrophe. Yet Atlas is no longer stable in the way observers once assumed. The pre-disruption state of 3 Atlas is defined by uncertainty rather than collapse. Centrifugal force continues to rise as rotation accelerates while cohesion depends on pathways already weakened by thermal cycling. Atlas exists in a narrow corridor where small changes may matter more than dramatic events. This corridor is what makes 3I Atlas compelling, because systems in transition often reveal more than systems in equilibrium. The deformation of Atlas's core signals that internal structure is now participating actively in the object's evolution. Rather than drifting toward quiet inactivity, 3 Atlas is responding dynamically to forces it can no longer ignore. This response does not end the story, but it deepens it. The altered shape of Atlas becomes a bridge toward understanding how heat rotation and internal composition interact over time. From here, the narrative of 3I Atlas moves inward toward the hidden processes that continue to drive change beneath the surface. Thermal influence within 3I Atlas does not end at the surface, because heat behaves patiently, migrating inward long after illumination fades. During perihelion, 3I Atlas absorbed solar energy faster than it could dissipate, creating a delayed thermal wave that continued travelling inward even as the exterior began to cool. This delayed penetration matters because it shifts activity from visible surfaces to hidden interiors, where volatile materials have remained sealed for immense spans of time. Within the interior of 3 Atlas, volatile compounds such as carbon monoxide, carbon dioxide, methane, and other low-temperature ices exist in pockets insulated by layers of dust and frozen material. These volatile reservoirs within 3 Atlas did not respond immediately to solar heating, but instead reached activation thresholds only after time had passed. When those thresholds were crossed, 3 Atlas began releasing energy in pulses rather than streams, altering the object's internal balance. Each activation event inside 3 Atlas produces gas that seeks escape through existing fractures and newly opened pathways. As gas expands within 3 Atlas, pressure builds locally before venting, exerting force not only outward but sideways through the structure. This internal venting transforms 3 Atlas into a system where force originates from within rather than being imposed solely from the outside. Thermal penetration reshapes the stress network of 3 Atlas by redistributing pressure unevenly. Regions that release volatile gas experience sudden pressure drops while neighbouring zones remain compressed, forcing material within 3 Atlas to adjust continuously. This adjustment does not occur smoothly because the internal architecture of Atlas is fragmented and heterogeneous. As heat continues its inward journey, the sequence of activation within 3 Atlas follows depth rather than time since perihelion. This means that 3 Atlas can remain dynamically active, even while retreating from the sun, defying expectations tied to surface cooling alone. The persistence of activity within Atlas therefore reflects thermal memory rather than immediate environmental input. Emotionally, this introduces a sense of delayed consequence because 3 Atlas behaves like a system still responding to an event already past. The sun no longer dominates the present state of Atlas, yet its earlier influence continues to echo within the interior. This echo gives 3 Atlas a temporal complexity where cause and effect are separated by distance and time. Thermal activation also reinforces rotational acceleration in 3 Atlas, because venting events rarely occur symmetrically. Each internal release applies torque depending on location and orientation, contributing incrementally to the spin behavior observed earlier. Through this mechanism, 3 at last links thermal history directly to dynamical evolution. Importantly, this process does not require exotic explanations to remain plausible. Thermal conduction, volatile sublimation, and pressure-driven venting are well-established physical processes, yet in 3 at last they operate under unfamiliar initial conditions. Interstellar origin means that Atlas carries a thermal and structural history unlike objects formed and weathered solely within the solar system. The activation of internal volatiles therefore reframes 3I Atlas as a delayed response system rather than a simple cometary body. Atlas is not merely reacting to present sunlight, but unfolding consequences stored deep within its interior. This unfolding reinforces the sense that 3I Atlas is still evolving rather than settling. As internal volatiles continue to activate the balance between cohesion and release within 3I Atlas grows increasingly delicate. Each new venting event modifies the internal stress map, subtly changing how Atlas will respond to subsequent forces. The future behavior of 3I Atlas thus depends not on a single trigger, but on an accumulating sequence of internal adjustments. This accumulation brings Section 1 to a close, because thermal penetration completes the picture of 3I Atlas as an object under layered transformation. Rotation, deformation, and heat now intersect within at last, establishing conditions that cannot easily return to prior equilibrium. From this point forward, 3I Atlas must be understood as a system carrying momentum, memory, and latent change into the next phase of its journey. The narrative surrounding 3 Atlas shifted most dramatically at the moment when motion appeared to pause without warning. Observers reviewing trajectory data noticed that 3 Atlas no longer followed a smooth continuation of prior projections even after accounting for known non-gravitational effects. What distinguished this moment was not gradual deviation, but an abrupt interruption that resisted standard interpretation. At the recorded time of the event 3, Atlas exhibited behavior consistent with his sudden loss of forward momentum. This was not described as deceleration in the conventional sense, because deceleration implies a continuous process governed by force. Instead, 3 Atlas appeared to encounter a boundary condition, as though motion itself had been momentarily constrained. Data associated with the event did not point to a physical impact in the classical sense. No debris cloud expanded outward from 3I Atlas, and no shock signature consistent with material collision was observed in optical wavelengths. The absence of such markers forced analysts to consider interactions beyond ordinary matter. Almost simultaneously, instruments designed to monitor spacetime itself recorded transient disturbances. Gravitational wave detectors registered signals that aligned temporally with the anomaly observed in 3I Atlas's motion. While these signals were brief, their coherence across multiple facilities reduced the likelihood of instrumental error. For 3 Atlas, the coincidence of dynamical interruption and spacetime disturbance suggested an interaction occurring at a deeper structural level. Rather than colliding with an object occupying space, 3 Atlas may have encountered a modification of space. Such a modification would not need mass in the traditional sense to exert influence. Spacetime deformation provides a theoretical framework capable of accommodating this behavior without invoking immediate contradiction. In general relativity, spacetime can curve, stretch, and constrain motion depending on energy distribution. If 3 at last entered a region where spacetime geometry differed sharply from surrounding space, motion could be altered without contact. This hypothesis reframes the event as an encounter with structure rather than substance. 3 at last would not have struck a wall, but crossed into a domain where the rules governing motion changed. Such domains are not predicted to occur naturally on small scales, which is why the observation unsettled existing expectations. Emotionally, this moment carries quiet dissonance rather than spectacle. 3 at last did not announce the event through explosion or fragmentation. Instead, 3 at last simply behaved in a way that demanded reinterpretation. The anomaly invites careful restraint because extraordinary interpretations require extraordinary grounding. Spacetime deformation can arise from extreme mass energy or exotic configurations, yet none were independently confirmed at the location of 3 at last. This gap between observation and explanation forms the heart of the uncertainty. For now, the collision event remains defined by what it was not. 3 at last did not slow, gradually did not ricochet, and did not disintegrate at the moment of interruption. 3 Atlas continued onward, afterward altered but intact. This continuation complicates interpretation. because it suggests a transient interaction rather than permanent obstruction. Whatever 3 at last encountered did not trap the object but influenced it briefly before releasing it. Such behaviour aligns more closely with field effects than with solid barriers. As a bridge within the narrative, this event transforms 3 at last from a stressed physical body into a probe of environmental structure. The trajectory of 3 at last becomes a line drawn through an unseen geometry. From this point forward, 3 at last is no longer only an object under observation, but a marker revealing the shape of the space it crossed. The most unsettling detail surrounding the encounter involving 3I Atlas was not the interruption of motion itself, but what followed across distant systems. Within moments of the event, satellites operating far from the trajectory of Atlas began reporting synchronized anomalies. Telemetry streams from independent platforms showed brief corruption, loss of precision, and timing offsets that appeared nearly simultaneous. The duration of these disturbances converged on a narrow window of approximately 11 seconds. That number emerged repeatedly as analysts compared logs from different orbits, frequencies, and hardware architectures. When patterns align across systems designed to fail independently, coincidence becomes an increasingly fragile explanation. For 3 at last, the significance of those 11 seconds lies not in severity, but in coordination. No single satellite experienced catastrophic failure, and no permanent damage was recorded. Instead, the disturbance behaved like a pulse touching many systems lightly before withdrawing. This behaviour resembles a field effect more than an attack or malfunction. Fields propagate overlap and influence regions without requiring direct contact. If 3 at last passed through such a field, surrounding infrastructure might register transient disruption without lasting consequence. The hypothesis of a quarantine zone emerges from this pattern not as a claim, but as an interpretive scaffold. A quarantine zone would not function like a barrier in the conventional sense. Instead, it would represent a regulated region of space, where transitions are monitored or modulated. Within such a framework, 3 Atlas becomes a test particle rather than a target. The passage of Atlas through a boundary could trigger diagnostic responses rather than defensive ones. 11 seconds would then represent the duration of evaluation rather than interference. This interpretation gains weight from the mathematical structure detected in subsequent signal analysis. Researchers examining noise bursts associated with the event identified sequences that resisted random classification. Simple numerical relationships appeared embedded within the disturbance, suggesting organization beneath apparent chaos. For 3 Atlas, the possibility that these patterns reflect intentional structure introduces philosophical tension. Intent does not require intelligence in a biological sense, but it implies design over accident. A designed field could regulate interaction without revealing its origin. Emotion enters subtly here because the idea of a quarantine zone reframes humanity's position without spectacle. Rather than invasion or contact, the concept suggests containment and observation. 3 Atlas, in this view, did not summon attention but brushed against a system already present. Such a system would not announce itself loudly because effective containment depends on invisibility. A visible boundary invites curiosity and resistance, while an unseen one enforces limits quietly. The disturbance associated with Atlas may therefore represent a rare moment when the boundary became briefly perceptible. The Orion arm mapping hypothesis extends this idea outward. If multiple regions show similar patterns of regulation, then the quarantine zone would not be local but distributed. 3 Atlas could then serve as a tracer revealing the presence of structure through interaction. Yet restraint remains essential, because absence of confirmation must temper imagination. Natural phenomena can mimic coordination, especially when analysed after the fact. 3I at last does not prove the existence of a quarantine zone, but it sustains the question. The 11-second window continues to echo because it resists narrative closure. It is long enough to register, short enough to evade explanation, and precise enough to matter. 3 Atlas carries that interval forward as a temporal scar rather than a resolved event. As a bridge within the story, this section shifts focus from object to environment. 3 Atlas no longer appears isolated within empty space. Instead, Atlas suggests that space itself may possess layers of regulation not yet accounted for. From here, the narrative moves deeper, because disturbance implies consequence beyond mechanics. The next question is not what 3I at last encountered, but what 3I at last became after passing through it. After the encounter, the most puzzling transformation associated with 3 Atlas unfolded not in motion or trajectory, but in composition. Spectroscopic readings collected in the aftermath revealed that material released from 3 Atlas no longer matched familiar signatures of dust and ice. Instead of resolving into known elemental patterns, emissions from Atlas appeared fragmented at a deeper level, as though molecular identity itself was dissolving. Atomic scale disintegration is not expected under ordinary thermal or mechanical stress. For 3 Atlas, temperatures were insufficient to induce nuclear reactions, and no radiation environment was present to strip atoms apart directly. Yet the data implied that bonds within Atlas were breaking in ways that bypassed standard energetic thresholds. This anomaly reframes the event as a transformation rather than a collision. Rather than shattering into fragments, 3 Atlas seemed to undergo a process where matter lost coherence without explosive release. Such behavior suggests interaction with a field capable of altering how matter organizes itself. Within physics, information is not separate from matter, because the arrangement of particles encodes state. If the encounter altered state without destroying mass, then 3 Atlas may have experienced a conversion from structured matter into structured information. This does not imply disappearance, but redistribution into forms no longer easily observed. The idea that 3 Atlas could transition into informational expression challenges intuition, yet remains grounded in theoretical precedent. Quantum systems already demonstrate that information can persist independently of classical structure. For Atlas, this raises the possibility that material coherence was temporarily suspended rather than eliminated. Spectral anomalies associated with 3 Atlas lacked the randomness expected from chaotic breakup. Instead, emissions showed consistency across time and wavelength, hinting at regulated transformation. Such regularity undermines interpretations based solely on accidental disruption. Emotion surfaces here as quiet astonishment rather than fear. 3. Atlas was not destroyed in the violent sense, yet it was no longer entirely the same. Atlas appeared altered in a way that suggested passage through a filter rather than impact with an obstacle. If matter can be reorganized into informational patterns, then boundaries in space may function as translators rather than walls. 3 Atlas would then act as input, with its internal state sampled and re-encoded during transit. This reframes the encounter as an exchange rather than a collision. Within this context, atomic scale disintegration becomes misleading language. What occurred to 3 Atlas may better resemble decoherence followed by reassembly. Such a process would leave subtle fingerprints without producing debris. The persistence of Atlas after the event supports this interpretation. 3 Atlas continued its journey carrying altered properties without catastrophic loss of mass. This continuity suggests that whatever process occurred preserved global integrity while modifying internal state. For narrative coherence, this moment deepens uncertainty rather than resolving it. 3 Atlas becomes a witness to processes operating beyond current observational frameworks. Atlas does not testify through speech, but through absence where presence was expected. As a bridge within the larger arc, this section moves the story from environment back to ontology. The question shifts from where 3 Atlas travelled to what 3 Atlas became. Matter behaving as information introduces a new dimension of interpretation that resists immediate closure. From here, the narrative must confront implication rather than mechanism. If 3 Atlas can undergo such transformation without annihilation, then the universe may contain interfaces invisible to conventional detection. This possibility prepares the ground for deeper reflection on whether transformation itself is the message 3 Atlas carries forward. The concept of a great filter has long existed as a theoretical explanation for cosmic silence, yet the behaviour surrounding 3 Atlas invites a reinterpretation that shifts the filter from inevitability to intention. Rather than imagining extinction as an accidental endpoint, the artificial filter hypothesis frames survival as conditional, and within this frame, 3 Atlas appears less like a victim of circumstance and more like a participant in a process. When the universe is viewed through this lens, 3 Atlas becomes a boundary interaction rather than an anomaly, because boundaries exist to evaluate transitions rather than prevent them. In traditional formulations, the Great Filter emerges from internal failures such as resource collapse, self-destruction, or environmental instability, yet an artificial version would externalize judgment while preserving autonomy. Such a system would not annihilate developing civilizations outright, but would instead observe how they respond to thresholds of capability, restraint, and coherence. Within this model, 3 Atlas functions as a probe event because probes reveal system properties without revealing the observer. If an artificial filter exists, its operation would likely be subtle, because overt enforcement provokes resistance, while silent evaluation encourages self-selection. 3i Atlas did not trigger alarms or declarations, but it produced quiet disturbances that were measurable yet deniable. This balance between visibility and ambiguity aligns with a test designed to observe response rather than force outcome. The idea of testing does not require moral intent because evaluation can occur without ethical framing. An artificial filter could operate as a diagnostic layer embedded within spacetime itself, responding automatically to certain configurations of motion energy or complexity. In this sense, 3 Atlas may have crossed a threshold that activated observation rather than punishment. Emotionally, this reframing carries a subdued weight, because a test implies agency without assurance. 3. Atlas does not confirm that humanity is judged worthy or unworthy, but it suggests that criteria may exist beyond immediate perception. This uncertainty produces reflection rather than panic, because tests reveal potential rather than fate. If the great filter is artificial, then failure would not be sudden, but gradual emerging through patterns of behaviour rather than singular events. 3 Atlas, by interacting with a possible boundary, hints that evaluation could be ongoing rather than episodic. Such continuity implies that the filter observes trajectories, not moments. In this framework, technological advancement alone would not determine outcome because capability without coherence may register as instability. 3i Atlas introduces the possibility that the filter measures balance, adaptation and restraint rather than power. The disturbance associated with Atlas becomes meaningful not because it harmed systems, but because it exposed sensitivity. This sensitivity matters because tests often reveal fragility before strength. 3. Atlas passed through an encounter that altered it without destroying it, suggesting that transformation can occur without erasure. That outcome mirrors the logic of a test designed to refine rather than eliminate. The artificial filter hypothesis therefore reframes cosmic silence as selective quiet rather than emptiness. If civilizations are contained, observed, or delayed rather than erased, then silence becomes an interval rather than an ending. 3 Atlas acts as a temporal marker within that interval, indicating that observation may already be underway. As this section closes, the Great Filter no longer appears as a distant abstraction, but as a process potentially unfolding in real time. 3 Atlas does not announce success or failure, but it suggests that thresholds exist, and that crossing them produces response. The test, if it exists, remains unanswered, because evaluation continues as long as motion does. In orbital science, residuals exist as quiet margins because they represent the difference between what models expect and what reality delivers. For a long period, the residuals associated with 3i Atlas behaved exactly as analysts hoped, scattering without pattern and dissolving into statistical background. Such randomness reassures observers because noise implies that the model remains fundamentally intact. That reassurance weakened as updated datasets were layered atop earlier projections, because the residuals linked to 3 Atlas stopped behaving independently. Instead of dispersing evenly around zero deviations, began to lean in the same direction, repeating their orientation across successive observation windows. When residuals align, 3 Atlas forces attention, because alignment implies memory rather than accident. Noise forgets itself from one measurement to the next, yet the residuals of 3i at last began to remember. Each update carried forward a similar discrepancy, subtle in magnitude but persistent in character. This persistence transformed residuals from bookkeeping artifacts into signals demanding interpretation. Analysts attempted familiar corrections, adjusting non-gravitational parameters to absorb the discrepancy, and for a time those adjustments appeared to help. However, even refined models failed to fully collapse the residuals associated with 3 Atlas back into randomness. What remained was a structured remainder, small but coherent, lingering beyond expected uncertainty. Structure matters because it narrows explanation. Random error offers infinite excuses while structured deviation demands a cause. For 3i Atlas, the residuals did not oscillate chaotically, but instead traced a slow, deliberate drift. This drift suggested that 3 Atlas was responding to an influence acting continuously, rather than episodically. A single burst of outgassing would produce transient deviation, yet the observed pattern implied sustained interaction. Such interaction challenges models built on passive evolution alone. Residual analysis also revealed temporal coherence. The shift in behavior did not smear across the dataset but appeared after a specific interval and persisted afterward. 3 Atlas thus marked a before and after within its own trajectory. Emotion emerges here as intellectual unease rather than alarm because structured residuals undermine comfort quietly. 3 Atlas does not violate physics outright yet. Atlas strains the assumptions that once explained motion cleanly. This strain occupies a grey zone where explanation exists but no longer satisfies. Within scientific history, such grey zones often precede conceptual expansion. Small repeatable deviations have previously signalled missing variables or incomplete frameworks. 3 Atlas now occupies that role not as proof but as provocation. Importantly, structured residuals do not imply intent by default. Natural systems can produce coherence under certain conditions, especially when internal processes synchronize with external forces. Yet the challenge lies in identifying which processes within 3 Atlas could maintain such consistency. As residuals accumulate, they reshape confidence rather than conclusion. Each aligned deviation slightly erodes the assumption that 3 Atlas behaves like known bodies under known forces. This erosion does not collapse understanding, but it widens the space of possibility. The transformation from noise to signal represents a threshold moment. Once residuals become structured, they cannot be unseen because future data must now answer to them. 3. Atlas carries this burden forward because its trajectory is no longer just a path through space but a record of discrepancy. This section closes not with resolution but with discipline. Structured residuals demand patience, replication and restraint because premature interpretation risks distortion. 3. Atlas invites observation without haste because signals often speak softly before they clarify. When structured residuals persist, the first instinct within orbital mechanics is not suspicion, but correction, because models are designed to be flexible rather than fragile. Researchers working with 3 Atlas initially assumed that refinement would restore alignment, as it often does when data grows denser and measurement precision improves. This assumption reflects confidence in frameworks that have successfully described thousands of bodies across decades of observation. For 3 Atlas, non-gravitational terms were revisited with care, and parameters associated with outgassing were adjusted to account for asymmetric mass loss. Radiation pressure coefficients were refined, and rotational coupling effects were reintroduced into simulations with greater resolution. Each modification brought the projected path of Atlas closer to observation, but never fully closed the gap. This partial success created an uncomfortable outcome because models improved without resolving the underlying discrepancy. The orbit of 3 Atlas could be made to behave acceptably, yet only through increasing layers of correction layered atop earlier assumptions. When a model requires continual accommodation, it raises the question of whether adjustment is masking limitation rather than revealing truth. Orbital adjustment implies agency, because something must actively alter momentum. For spacecraft, such changes signal course correction, while for natural bodies they usually indicate transient forces that decay over time. In the case of 3 Atlas, the deviations neither decayed nor spiked abruptly, but instead persisted with coherence. This persistence challenges the passive object paradigm. If Atlas were simply shedding material irregularly, the resulting forces would vary chaotically, producing noise rather than pattern. Instead, the observed behavior of 3 Atlas suggests continuity that resists easy categorization. At this stage, the question shifts subtly from what forces act on Atlas to whether the model itself captures the relevant degrees of freedom. Classical orbital frameworks assume environments shaped primarily by gravity with minor perturbations. 3 Atlas appears to operate within an environment where those perturbations may no longer be minor. The limits of the old model become visible not through failure but through strain. Predictions remain broadly accurate, yet they feel increasingly constrained as though reality is pressing against the edges of permitted explanation. For 3 Atlas, this pressure accumulates quietly, because nothing dramatic breaks. Emotionally, this stage introduces intellectual tension rather than narrative shock. There is no moment of collapse, only a growing sense that explanation is working harder than it should. 3 Atlas occupies a space where understanding is adequate but no longer elegant. In scientific practice, elegance often signals completeness, while awkwardness hints at omission. When adjustments pile up without convergence, the risk emerges that the model is compensating rather than clarifying. 3 at last therefore becomes a mirror reflecting the assumptions embedded within orbital theory itself. This reflection invites restraint because discarding established frameworks prematurely risks error. However, clinging to frameworks beyond their domain also delays insight. The balance lies in recognizing when adjustment serves understanding and when it serves comfort. For 3I at last, the distinction remains unresolved. Orbital corrections continue to function, yet they no longer feel definitive. Each update restores temporary alignment while leaving residual structure intact. This pattern suggests that 3 at last may be interacting with influences not fully parameterized within existing equations. Those influences need not be exotic, yet they may operate in combinations unfamiliar to models calibrated on solar system history. Interstellar origin alone grants at last a different baseline of composition, cohesion, and response. As analysis proceeds, the question becomes less binary. Rather than asking whether 3 at last is adjusting its orbit, or whether models are failing, the more precise inquiry asks how much adjustment a model can absorb before it ceases to explain. 3 at last now sits at that boundary. This boundary does not demand immediate revision, but it demands attention. Old models continue to guide prediction, yet they do so with diminishing authority. 3I at last invites a posture of listening rather than concluding. The trajectory of Atlas remains traceable, yet its meaning grows more complex. Orbital adjustment may describe the motion, but it does not yet explain the cause. This unresolved gap carries the narrative forward because limits once revealed cannot be unseen. As discrepancies accumulated around 3 at last, an absence became as noticeable as any anomaly because explanation failed to accompany data with the same persistence. Updated releases concerning 3 at last arrived stripped of interpretive commentary, leaving numbers exposed without narrative context to frame their meaning. This silence does not imply concealment, yet it creates a vacuum where uncertainty expands rather than contracts. In scientific practice, annotation functions as guidance because it reveals how researchers interpret deviation and why specific assumptions remain valid. When 3 at last updates omitted such framing, external analysts were left to infer intention from output alone, a process prone to misalignment. The gap between measurement and explanation thus widened around 3 Atlas not through secrecy, but through omission. Silence often emerges from caution rather than avoidance because premature interpretation can mislead as easily as speculation. For 3 at last, restraint may reflect recognition that existing frameworks do not yet support confident explanation. Yet restraint carries consequence because uncertainty unaddressed does not remain neutral. As the interpretive gap persists, normalization becomes a risk because repeated exposure to unexplained deviation dulls sensitivity. Each new dataset involving 3A at last appears only slightly different from the last, encouraging acceptance rather than inquiry. Over time, anomaly risks being absorbed into baseline without ever being understood. History demonstrates that many pivotal discoveries began as quiet discrepancies left unremarked until context shifted. 3. Atlas now occupies a similar space where deviation exists without urgency, yet refuses disappearance. The absence of explanation becomes part of the phenomenon rather than a temporary state. Emotionally, this silence generates unease not because of implied intent, but because of epistemic discomfort. 3A Atlas does not demand belief yet. Atlas resists closure. The mind seeks narrative resolution, and silence denies that instinct gently but persistently. Scientific institutions often rely on thresholds to trigger commentary because resources prioritize anomalies above predefined magnitude. 3I Atlas challenges this approach because significance here arises from coherence rather than size. Small deviations aligned over time demand attention even when thresholds remain unmet. Automation within data pipelines further compounds the gap. As processes streamline publication, human interpretation may lag behind numerical output. 3I at last thus illustrates how efficiency can inadvertently suppress reflection. The interpretive gap surrounding 3I at last does not accuse science of failure. Instead, it exposes tension between speed and understanding, between precision and meaning. When data outruns narrative, uncertainty grows fertile. This moment invites patience rather than urgency because silence can signal an unresolved question rather than a resolved answer. 3. Atlas continues to move while explanation hesitates. That hesitation becomes instructive. As this section closes, the absence of commentary around 3I Atlas stands as a reminder that knowledge advances unevenly. Numbers may arrive on schedule, but understanding arrives when frameworks catch up. Until then, 3I at last remains suspended within an interpretive gap that quietly demands attention rather than reaction. A knowledge inflection point does not arrive with spectacle, because it forms when accumulation quietly exceeds accommodation, and 3 at last now inhabits that threshold. Across successive observations, 3 at last has not invalidated physics yet. At last has exposed where explanation strains to remain sufficient, and that strain signals transition. When models continue to function but lose elegance, understanding does not collapse, it prepares to evolve. For 3 at last, the invitation is subtle, because the data does not demand abandonment of established frameworks, yet at last insist that those frameworks widen. This widening is not a rejection of gravity thermodynamics or orbital mechanics, but an acknowledgement that their current combinations may be incomplete for interstellar conditions. 3I at last therefore reframes progress as integration rather than replacement. Historically, inflection points emerge when small persistent deviations refuse to disappear, and 3I at last has carried such deviations forward without escalation or retreat. The behaviour of at last encourages a slower posture, one that values coherence over magnitude and pattern over drama.